EASYZON is supplied in two configurations. The modular frame is suited to integrators who already have tanks and dosing pumps, enabling direct injection at low back pressure and eliminating separate dosing pumps. The skid version is a floor-standing package with integrated tank and controls, factory-tested and ready for rapid installation. This slide details the EASYZON modular unit footprint. The cabinet measures approximately 734 millimeters high, 750 wide, and 333 deep, with a weight of 32 kilograms. These compact dimensions allow simple wall or frame mounting and make it easy to integrate the generator into existing plant layouts. Here we see the EASYZON skid dimensions. The skid is 1,193 millimeters high, 778 wide, and 797 deep, with a dry weight of 85 kilograms excluding the modular cabinet. This information is essential for planning plant room space, access routes, and foundations before installation. This equipment overview identifies the main components of the EASYZON system. Key items include reagent inlets and metering, the HMI dilution water inlet, reaction vessel, gas scrubber, product tank, and bund flood float switch. Understanding these elements supports effective operation and maintenance. The model range summary shows 20 EASYZON variants. Selection is based on required ClO2 capacity, reagent strength, low, medium, or high, and whether a modular or skid configuration is preferred. L models cover 125 to 250 grams per hour, M models up to 500 grams per hour, and H models extend to 2,000 grams per hour. This reagent consumption table links generator capacity to daily chemical usage for L, M, and H strength reagents. It helps determine storage volume, delivery frequency, and dosing pump sizing. Higher capacity systems benefit from higher strength reagents to minimize chemical consumption and logistics costs. The scope of equipment diagram shows how EASYZON connects to acid, sodium chloride, and product storage tanks. Standard supply includes suction demand valves, a water pressure regulator, and connection sets. For high-strength reagents, PTFE suction lines are recommended to ensure chemical resistance and safety. This unit process diagram explains the internal flow path. Acid and chlorite enter through metered inlets, pass solenoid valves and flow meters, then react in the vessel. The adductor and dilution water create the final ClO2 solution, which exits to the process. Non-return valves protect against backflow. Design and function are based on a controlled batch sequence. Reagents are drawn into the reaction vessel under vacuum, forming a concentrated ClO2 solution. After a fixed reaction time, the solution is diluted and discharged. Modular units feed a process or tank, while skid systems include a 200-liter storage tank and safety features. This slide highlights critical site considerations from the datasheet. Reagents must be kept between 10 and 30 degrees, and inlet water pressure between 0.2 and 0.3 MPa. Ambient temperature, water quality, and supply voltage all influence performance. Lines exposed to cold conditions may require lagging or trace heating. Before quoting EASYZON, a structured survey is required. We confirm potable feed water, pressure and metering signals, ambient conditions, and storage facilities. We also define whether modular or skid equipment is needed, dosing pump requirements, gas detection, analyzers, communications interfaces, and any water testing equipment. The system size calculation tool supports engineering design. By entering site data such as background ClO2 demand, peak and average flows, and water meter K-factor, the spreadsheet calculates required generator capacity, batch size, reagent usage, product tank volume, and expected delivery frequency. This HMI process mimic screen provides a real-time overview of the batch. Operators can see ClO2 generation rate, batch completion, product tank status, and valve positions. From here, they can access alarm summaries, PLCIO screens, and navigation buttons, enabling intuitive monitoring and control. The HMI home screen is the main operating hub. It displays system ID, real-time ClO2 output, and overall health status. From this screen, users can enable or disable manual inhibit, review alarm history, check chemical usage, and navigate to process mimic, settings, and maintenance menus. The chemical usage screen tracks acid and chlorite consumption. It shows real-time tank volumes, usage since last refill, daily and weekly totals, and estimated days to refill. Service functions allow reset, priming, and refill sequences, supporting accurate inventory management and safe operation. On the chemical refill screen, operators enter the new fill volume after topping up each tank and confirm the value. They can also set a low-level warning threshold. This ensures the HMI provides timely reminders before chemicals run low, reducing the risk of unplanned shutdowns. The PLC I/O screen displays live status of all digital and analog inputs and outputs. Operators can quickly verify signals from water meters, level switches, and emergency stops, and confirm operation of valves and relays. This is a powerful diagnostic tool during commissioning and fault finding. Settings Screen 1 is used during commissioning. Here we define system, reagent, and site tags, select the stopped condition, confirm factory set capacity, and set display timeout. We also link external signals such as remote inhibit, bun flood, and tank level switches, depending on installed devices. The maintenance screen manages lifecycle support. It records operating hours, service due dates, and reactor change intervals. Technicians configure IP network settings, Modbus communication, language selection, and software revision. Service and reactor resets are logged to maintain traceability. The PLC alarm history screen logs all events with time, severity, and value. Operators can scroll through alarms and press the information icon for detailed guidance on corrective actions. This structured history supports root cause analysis, improves response times, and strengthens operational compliance.